Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Epimers are monosaccharides that differ in configuration at only one specific chiral carbon. C2 epimers specifically differ only at carbon 2, C2. Moving on to the next step. Recall the definition of C2 epimers. Two sugars are C2 epimers if they have identical configurations at all chiral centers except C2 where they have opposite configurations. Moving on to the next step. Analyze option B, D-glucose and D-mannose. D-glucose has the configuration at C2 as R, or on the right in Fisher projection. D-mannose has the configuration at C2 as S, or on the left in Fisher projection. At C3, C4 and C5 both D-glucose and D-mannose have identical configurations. Therefore, D-glucose and D-mannose differ only at C2 making them C2 epimers. And for the final step, eliminate other options. Option A, D-maltose is a disaccharide, not a monosaccharide, so it cannot be an epimer of D-glucose in the classical sense. Option C, D-allose is a hexose and D-ribose is a pentose. They have different carbon chain lengths and cannot be epimers of each other. Option D, D-glucose and D-arabinose differ at C2 and C3 and are also different chain lengths, hexose versus pentose, so they are not C2 epimers. Confirm that D-glucose and D-mannose are the classic textbook example of C2 epimers among the aldohexes, differing solely at the C2 hydroxyl group orientation. Therefore, the correct answer is B. Therefore, the correct answer is option B.